Hello, my name is Michael Ogezi, and I will be presenting our work at SemEval 2023 Task 1. Our work is titled Context Augmentation and Translation for Visual Word Sense Disambiguation. This is joint work, and it is supported by Amy, the University of Alberta, and NSERC. So we're going to start with our takeaways and main findings. So first, we find that augmenting context significantly improves semantic understanding. The second thing we find is that the English language bias that is well known in the broader field of NLP also extends to the vision language case. So here's our task. Given a focus word in context and a set of candidate images, we seek to determine which image best depicts the meaning of the word. So here's an example. We have the focus word bat within the context baseball bat. So we're supposed to see what image best depicts the meaning of bat within baseball bat. We have 4 options here. In reality, in this task, there are more images, but we seek to select the best one anyways. And this is working well enough for our purposes. So we have the first image, which is a baseball bat, the second image, which is a mammalian bat, the third, which is Batman, and the fourth, which is a group of baseballs. And if we get a system that understands what bat means in the context of baseball bat, we are easily able to select the first image. So I'm going to go on to the method. So the 2 major components of our method are context augmentation and translation. And for context augmentation, we take in the context and generate some extra context that is able to augment the phrase that we are focusing on. So we see here that we pass in the short context of baseball bat, and we are able to get a language model to add words that help elucidate what this phrase means. And we get a baseball bat is a cylindrical club used to hit a baseball, which sort of further clarifies what we mean by bat. The second component is translation, and here we have an Italian phrase, Alfiere si muove in diagonale. And we use a translator to convert this Italian phrase into English, and we get Bishop moves diagonally. And now we can use an English models which are typically way more powerful to extract meaning from this phrase. The third and final component where we are able to make a prediction is image scoring. And the intuition behind this is simple. We pick the image with the strongest affinity to both the context and the glosses of the senses of the focus word. So here is a diagrammatical display of how our system works. So I'm going to talk about the 3 components of the image scoring algorithm. So first, we compare the candidate's images to the context, right? Here we use something like clip, which can encode both images and text in a similar semantic space. By doing this, we get a similarity score for each of the images and the context. Second, we compare the candidate's images to the glosses. Here we see 2 glosses of the word bat. And we are able to get multiple similarity scores for each gloss compared to each image. And third, we compare the context to the glosses. And distinct from the other 2 steps, here we compare text to text. And we compare, for example, baseball bats to all the glosses of bats. At the end of the day, after computing these 3 steps, we want to sum the scores and normalize into a probability distribution. And at the end of the day, we pick the image that corresponds to the largest value in the probability distribution. So I'm going to describe our experiments now, starting with our baseline and our methods. So first, the baseline. Here we compare images to context with multilingual models. And what this means is that we use a single model to process context from English, Farsi, and Italian. So that is done by one model. The second is language specific. And as the name implies, here we seek to use different models specifically trained for each of the languages to process the context. So for English samples, we use an English model. For Farsi samples, we use a Farsi model, and so on. And we want to compare the context in different languages to the images that we are to score. Third, we have GenDef, which is image generation with context augmentation. Here, instead of directly comparing the context to the images, what we do is generate an image or an ensemble of images from the context and compare those images to the candidate images. And we simply select the image that is most similar to the generated images. And finally, we have translation depth, which is the method we described earlier, our primary method. So how do these methods perform relatively to each other? That's what we're going to talk about now. So here are our results. So we have English in light blue, Italian in dark blue, and Farsi in orange. And we have first the baseline, second GenDef, third LangSpec, and third TRDef. And we have spoken about what these different methods and baselines mean previously. So at first we can see that the baseline method performs decently well. There isn't a large gap between it and TRDef or other methods specifically for English. But we can see that since there is usually an English bias, it performs poorly on the other languages, namely Italian and Farsi. And this is one of the points where we see that TRDef really shines, because after translation, we are able to sort of put English on a more equal footing to other languages such as Italian and Farsi. And we see that by the large gap we're able to gain. So we also consider GenDef, which is interesting because it is an indirect approach to the task. Remember that here we are generating an image from the context instead of using the context directly. And we see that it performs decently well. This is, on average, our second best performing method. And third, we have LangSpec, which is a bit surprising because you would expect that a model that is specifically trained for each language, specifically trained for English or Italian and so on, would perform better than something that uses translation. But we in fact find that this is not the case, and translating any of those languages to English, even with the inherent error that would accompany that, still performs better than using language-specific models. And I think this is very interesting. So, on to our conclusions. So first, we find that context augmentation improves performance considerably in our task, an average of 20% across our languages, English, Farsi, and Italian. And secondly, as we alluded to just a few moments ago, English-only clip on translated text with all the inherent error with that yields higher accuracy than language-specific clip on original text. And I think that's very interesting and suggests that more work needs to be done to overcome the English bias that is creeping into vision language tasks. Thank you very much.